Hello, good evening, and welcome to tonight's Star Party. I am Amy Archer, and I will be one of the co-hosts for tonight. Laurie Roche will be the other host this evening that you'll see. Tonight's Star Party is titled Canada's Future in Space, and our guest speaker this evening will be Randy Attwood. Randy will be talking to us a bit about the Artemis missions. Canada, of course, has a long history in space exploration, using scientific space probes to explore the new frontier and sending Canadian astronauts into space. The Artemis program will give our astronauts the opportunity to travel beyond low Earth orbit, to the moon, maybe even down to the lunar surface. Tonight, Randy's talk will take a look back at Canada's history in space and look ahead to the Artemis program. For tonight, we will also be taking a quiz about the moon, and we'll, of course, get the results of the moon giveaway. Thank you to everyone who participated in that. We'll also hear some astrophotography tips and tricks about the moon, and a special Ask the Selenophile segment for this evening. But before we get started, I want to take a moment to center our time together. I would like to tell you a little bit about the beautiful land that our observatory sits on. We are so grateful to work, learn, collaborate, and play on the traditional lands of the WSÁNEĆ people, who have been the custodians of this land long before the arrival of Europeans. We respect the continued connection with the past, present, and future with the Indigenous peoples within the community with whom we all share this wonderful night sky. I again encourage you to find out a little bit about the history of the land that you're, tuning in from this evening, and just to respect that space. I'm going to start us off tonight with turning us over to Laurie and Calvin, who are going to give us a bit of a quiz.
All right. Hi, everybody. My name is Laurie, and I'm going to be helping Calvin here to do a little bit of a quiz. We thought maybe we'd start off with what you people know about the moon. Calvin has set up a series of questions that he's going to put up, and we'll all just kind of fill in the answers really fast, and then we'll be able to find out what some of the answers are. We're putting this tonight on another not just on the Zoom poll, because then that would make it so that the people on YouTube cannot right. access that. So what Calvin is going to do is to put up a link in the chat, and so you'll have to kind of have a look at the chat and click on that, and then answer the question, and then come back into us in order to be able to see what some of the answers are. Some of them are harder than you think. So there you go.
That's right. I just kind of came up with them on a whim, whatever I thought was interesting. So hopefully they should still be entertaining if they're not easy.
And it's okay. There's no like prizes for the person who gets all of them right or anything like that. So
that's
anyway,
right.
Okay.
So I'm going to start off with the first question. So I'm going to paste a link into the chat. So into this one, and I guess also I can paste it into YouTube.
Okay, so go ahead and you can link into the first question, put your answer in, and do submit.
I think that works. So the folks over at YouTube should be receiving that link too. So you can click on that, and then while we're waiting for people to answer, I can talk about this first question, because the question one is, how many Earth days are in a lunar day? So if you were on the moon and you waited there from sunrise to sunset and then back again.
Question.
Sunrise to sunrise. How many Earth days are there in that lunar day? Let's see if I've, okay, so I can maybe share the screen so I can see the results. One moment. So I click share and then I click this one. Hopefully I don't end up sharing the answers right away. Okay, so this is the summary here. Looks like many people said 29 days, and a few people said 7 days or 365 days. And if I refresh the page, is there more, or is there, that might just be it. Well, there we go, a few more.
Okay.
All right, so 9 people said 29 days. Lori, what do you think the answer is? Do you know this one?
I think it's 29 days.
Yeah, I think so too. That's because that's has to do with how like the moon orbits the Earth, right? The it's orbiting the Earth, and it takes a month to orbit the Earth, and so it takes that amount of time to see the sun go all the way around. Let's do the next question.
Question 2.
So I think that's a decent number of responses, right? It was at least 14.
Sure. Yeah.
And maybe some more trickled in that I didn't have time to look at. Okay, I'm gonna start putting in question 2 to keep things moving.
Yep. Yeah. Keep things moving along. There we go.
So this should say question 2.
And how many Earth days does it take for the moon to go around the Earth once?
Thanks, Lori.
1 day, 7 days, 29 days, 365 days.
And I will then share my screen again so we can take a look at the results. Hopefully we can all see that. Looks like there's 8 out of 8 responses here. Most people said 29 days. So how many Earth days does it take for the moon to go around the Earth once? Well, it's the same as the other thing I said, a lunar day. And of course, that's all because of the tidal locking and all that, right?
Trick questions.
It's a bit, yeah, a bit tricky. There we go. Okay.
Okay, let's try number 3.
Sweet. Let's do number 3. Yeah, and if it ends up taking too long, we don't have to go through all the ones that I wrote.
Well, we could maybe do a couple more later on if we need to.
Yeah. Okay, so this should be question 3.
Okay. Okay, what moon phase does the moon enter into after a new moon? Waxing gibbous, waxing crescent, waning gibbous, waning crescent, or old moon? Okay, submit your answers.
We can look at some results here.
Ooh, not many people answered.
Hmm,
Oh, no,
we
there
go.
they are.
That's 14
Oh.
now.
there we go. Yeah.
Yeah. Waxing crescent. So that's going, yeah, I always like to say old moon because it goes from a new moon to an old moon, I figured. But I guess before it gets old, yeah, waxing crescent because it's going from dark to lighter again. So it's waxing, it's getting brighter. I guess that's what that means.
And David Lee, a little bit later, is going to be showing us a little bit of those moon phases. And so you'll get a chance to have a look at those. Yeah. All right, next.
Yes, question 4 is starting to tumble down the hopper there.
Okay. Question 4. What are the dark plains on the moon called? Maria, canals, the Great Plains, or seaplanes? Now you know what I have to put up with when I deal with Calvin.
I think you gave it away when you said seaplanes, way about planes.
Hmm.
Okay.
All right, I
Seaplanes.
should bring up these results next for question 4.
All right.
This button. Okay, 13 responses. Mostly everyone says Maria.
Yeah.
That's right.
And they certainly are great. I mean, they are great planes as well.
Yeah,
I
they're
mean,
pretty
absolutely,
great
they
planes.
are
That's why I was hesitant to
are.
put that as an answer because
I think
I was
that's
like,
great,
well, I
yeah.
guess you could say they're planes, and they're quite great.
But they are the darker, flatter kind of areas on the moon that have where the material that was underneath has gone over the top and spread over where some of the craters were, and it's a different kind of material that is from underneath the moon from what the highland areas are that are a little bit whiter on the moon. Okay,
Right.
maybe one more, Calvin.
Okay, one more,
Yeah,
and then
one
we'll
more.
move on. Awesome. Okay, it's in the chat.
There we go. Which side of the moon has more craters? The far side, or farthest from the Earth, the near side, closest to the Earth, the leading side toward the direction the moon is moving, or the trailing side away from the direction the moon is moving.
So that I wonder if this one's a bit on the confusing side. And
Could be.
And I think I only know this answer. I don't know for sure if like maybe there's some sort of technicality where one side is technically has more craters than some other one, but there's a general trend, and I'll show the results, which I think most people got right. The far side, because that's where those Maria aren't. There's way fewer Maria there. So there's less of that lowlands, whereas that volcanic stuff that Lori mentioned, where it's kind of erased any craters that might have been there. And I figured I threw in leading side and trailing side because I wanted to add more answers.
All right. Well, maybe Calvin, we can come back to the couple that are left at the end. Thank you. We're going to move on to somebody who knows way more about the moon than either Calvin or I. And I'm really pleased to introduce Randy Attwood to you this evening. Randy is in Mississauga, Ontario, so it's already 10:15 his time. So thank you, Randy, for sticking out with us here. Randy has a long history in working with space and space missions and astronomy in general. He's an astrophotographer. He is an eclipse chaser. Ask him about eclipses later if you want to. He is a historian. He has done an awful lot of work as hosting in various media. And he was the president of the Royal Astronomical Society of Canada for a number of years, and then became the executive director of the RASC for a number of years. And he now is I guess chairing a number of committees that look at the eclipses that are coming up in 2023, 2024. He also is very active in his own club in Mississauga, and you just can never ever keep Randy down. So I'm really happy to say that Randy is probably the person in well, I mean, that I know in the RASC that knows more about the missions for Apollo missions and for some of the work. Well, I mean, Chris Gaynor, you're online too. I mean, what more can I say? For heaven's sakes, yes, the two of you. And I'd like to introduce Randy to you, and I'm going to give him the floor to talk a little bit about some of the past missions and looking forward into Artemis coming online. So Randy, you can take it over.
And you can also start your video if you want to do that too.
Start what?
Oh, your video is not currently showing, so I can't show you on screen right now.
Oh, I see.
Unless you didn't feel like doing that, that's fine.
Oh, right. For to see him.
Yeah. No. If I can't leave the room if my video's on, right? Just kidding.
All right.
Yeah. No, I'd have to unshare to turn that on. So I think we'll just leave it off for now.
Okay.
Thanks very much, Lori. And oh, okay. I see that you have a way to do that. There we go. Yeah, very pleased to talk to my friends in Victoria and across the country about this new program, Artemis, which will see Canada participating in a return to the moon. I thought a good place to start would be to talk a little bit about the history of Canada in space. And to do that, I think we need to go back several years to when we first started sending rockets up. As many of you know, the rocket development took place mainly in the 20th century. Two men were involved with that, Robert Goddard, an American, and Werner von Braun, a German. And it wasn't really until the 50s that rockets became dependable enough that people could consider using them to do science. And there was an international geophysical year in 1957, 1958, which was meant to do some scientific exploration of our upper atmosphere and even in the space environment. And there was a race to send the first space probe up into orbit, and the Soviet Union were successful. They developed some rockets that could take heavy payloads up into orbit, and they were the first with Sputnik 1. The Americans were competing, and they followed not long after that with their first attempt, which was not successful. So the Russian attempt was Sputnik, and the American attempt was a Flopnik. But it wasn't long after that that the Americans put their first space satellite into orbit. Now, the capability of the Soviet Union having this, being able to put large payloads into orbit really concerned the US, because they thought that the Soviet Union could drop bombs down on them from space. So there was a great rush to build some sort of defense and develop rockets. But also there was a real drive to educate the American youth with STEM topics. And in fact, each school board was given a relatively sophisticated planetarium that they could set up in their schools. Many of them are closed now, but I was really surprised to learn this when I went to a planetarium conference in the States, that each school board actually had a planetarium in the 50s, early 60s. As a result of Sputnik, not long after that, NASA was created, a government organization to oversee space exploration, both uncrewed and crewed, and the space age had begun. Meanwhile, in Canada, the implications were mainly interest from our point of view, but also defense, because again, we are right in between the US and the Soviet Union. So there was some concern there as to how that would affect us. The National Research Council and Defense Research Boards were created, and scientists began to look at studying space above Canada. We have the North Magnetic Pole in Canada. I think we still do, although it's on the move. But there was interest in studying the upper atmosphere, ionosphere, such, and using the ionosphere for communications. Around the same time, we were developing a interceptor aircraft for our own defense. It was the first one was actually rolled out on the day Sputnik was launched. But that project was canceled a few years later for reasons that we could probably do another talk. But the implications of that did help Canada's space program, and we'll talk about that. So Canada was the third country to send up or to build a satellite. We've never put a satellite into orbit. We don't have a rocket launching pad, although there are some plans to develop the capability to launch small payloads into orbit from the East Coast, such as Nova Scotia. But we had the Americans launch our first satellite, the Alouette, which was a scientific satellite to look down on the ionosphere. And so it was a science satellite. It was mainly built in Toronto. If you know where the Yorkdale shopping mall is and the Downsview Airport, it was built up there. And it was a really interesting story as to how that was built, thrown together. And, there were no manuals on how to build these things. So these ingenious engineers built this thing that worked for quite a long time. We also developed something called a STEM. Don't confuse it with STEM that we talk about with teaching, but it's essentially the capability to store metal in a roll that when unfurled would become a tube. So it's essentially something that can create a long tube, and that was used as antennas for Alouette and has been used on other space missions. So along the way, that's what we began to do in the 60s. We built scientific satellites and we did launch scientific payloads up into the higher atmosphere from places like Churchill, Manitoba, these so-called sounding rockets. But they just came back to Earth and usually just transmitted their information, or the payloads were recovered. But this rocket launching area was used for quite a while on the shore of Hudson's Bay. In the mid-60s, the government essentially was looking for some direction as to where to go in the future for Canada's space program. And John Chapman, who's considered to be the father of Canada's space program, wrote this report, which dealt with using space to develop communications capability, looking down and observing the Earth, and developing a space industry, a formal space agency, and developing places where we could test our satellites before they were launched into space. So this was a critical point in our history of space exploration. One thing that Canada has done really well, pretty well because they had to, and that is cooperated with other countries on various space programs. So we would put scientific payloads on other countries' satellites. Here, this satellite, the University of Calgary supported it with providing a UV camera to look at the northern lights from above. The Upper Atmosphere Research Satellite, which was launched by the shuttle, we put a scientific payload on that. We were involved with launching something called SciSat, which had many experiments, atmospheric experiments. And we built our own small space telescope. Many of you know Jamie Matthews at UBC, know that this was his baby. Essentially, he called it the Humble Space Telescope because it cost a small percentage of what it cost to build Hubble. And but it was quite a successful project. And here is most in the clean room at the University of Toronto, not long before it was sent to Russia, or the Soviet Union, I guess it would have been Russia, to be launched. So it was a clean room, so you had to wear your bunny suit if you wanted to get close to it. Here are two of the fathers of MOST, Slavik Ruchinsky, who's a U of T astronomer, and Robert Z, who is an engineer at the U of T satellite developing place, UTIUS. I forget how the acronym goes. But it was really quite an interesting project, because Canadians have always had to do things not on the cheap, but for a lot less money. And we had to develop our own reaction wheels. The MOST didn't have a rocket propulsion system. It turned by speeding up and slowing down reaction wheels, which were arranged at 90 degrees to each other. And Kieran Carroll, who actually was living in Mississauga at the time, developed these for MOST, which have been used on other satellites. So that's what MOST looks like flat on a table. It's kind of a sort of a pre-autopsy of MOST, I guess, or something. But anyway, that's what a satellite looks like when they're testing it before they put it all in the inside the can and send it up into space. A follow-on to MOST has been NEOSat, which was essentially using the same design as MOST, but instead of looking up at stars, which MOST did, it looked down at the Earth and looked for potential, looked at surveilling satellites, but also it looked out looking for potential small asteroids that could collide with the Earth. In the 2000s, nanosatellites became the big thing. Very small satellites that could be launched, many satellites on one launcher. And in fact, there is a contest for university students to design and build satellites, which are ultimately launched into space now. So it's quite a neat program. A follow-on to MOST was the BRIGHT satellite. And again, very small, but very functional and able to do science for a reasonable amount of money. Canada's very, very large, lots of room, and people are spread out. And so Canada saw using space technology to be able to communicate. And the first communication satellite sent up was in 1972 called Anik. And it's these communication satellites are placed above the equator such they can see all of the country and provide the ability for people to communicate using phones and other various devices, especially for the North. It really opened up the North with communication capability. So there've been a series of communication satellites through the 70s and 80s and right into the 2000s. Many of them different versions of Anik, and Nimiq came on board in the late 90s. One of the first ones, one of the Aniks, C3, was actually on this, the 5th shuttle mission. This is a picture I took of Columbia on the pad the night before, and the launch. So just the 5th shuttle. This is the first shuttle to take up any kind of a payload for paying customers. And as you can see, Canada got its own, Telesat Canada got its own little logo placed beside the countdown clock there. But half a year later, another Anik went up on Challenger on Sally Ride's mission. And that's a view of what dawn looked like on the day of that launch. There's a painting by a friend of Chris Gaynor and mine, a good friend, Paul Field, another Canadian, who's depicting what the Anik looked like in space. We talked about Earth remote sensing. The Landsat satellite is a series of satellites that the US have put into Earth orbit to look down at Earth resources. But they only work during the day, or at least they're taking pictures during the day. And if it's cloudy, then you don't get any results. Well, Canada developed a satellite which looked through clouds and can be used at night called RadarSat. And that's a capability of using radar to take images like this. And the RadarSat program has sold a lot of pictures to countries all around the world with information taken from space. Another program Canada was involved with is search and rescue. So thousands of lives have been saved because aircraft have carried these transmitters that would turn on if there was say a boat or a aircraft was in trouble, and it would send a signal up into a satellite, and there would be a rescue effort started. So we've developed a place to test all these satellites called the David Florida Lab in Ottawa, which is quite an amazing place. I actually saw one of the radar sats being tested when I visited there many years ago. And we do have a space agency in Saint-Hubert, Quebec, and it's named after John Chapman, who wrote the Chapman report. So Canada's also been involved with projects to go to the planets. One of the first projects to go to Mars was Mariner back in the 60s. There have been several landers on the planet Mars and rovers. And Canada has been involved with a lander called Phoenix. And when it landed about 15 years ago, it had a weather station. And on this weather station, there was a LiDAR system, and it was able to essentially provide information on the environment on Mars. And there you can see the LiDAR system is bagged with a little Canada logo. So Canada has been involved with the Martian program, and it's also is involved with the OSIRIS-REx program, which is a spacecraft that actually touched down on a asteroid about a year ago now, or maybe even longer. I'm losing track, but it's now on its way. It took a sample of the asteroid, and it's now on its way back to Earth. And when it gets back here, Canadian scientists will have part of that sample of an actual asteroid to study. Now, talking about sending people into space, as I mentioned, the Avro Arrow was built and was being developed and then was canceled around the same time that the Americans were selecting their first astronauts. As a result, NASA hired about 35 or so engineers who were working on the Avro Arrow and took them down to the States, to Langley, Virginia, where the NASA, I guess the manned space program was being headed for NASA. And many of these, we met many of these gentlemen at the 25th anniversary of the Apollo 11 moon landing. There was a conference here in Toronto, and I think that's where I met Chris Gaynor. He was there as well, and we had a chance to meet these people who essentially had contributed to the success of the Apollo program. And as a result of that, Chris tells me that's where I think, well, he can correct me if I'm wrong, but I think he got the idea to write his Arrows to the Moon book, which is an excellent history of how these Avro engineers helped with putting people on the moon. One of those people was Owen Maynard, someone who we got to know very well. Grew up in Sarnia, flew mosquitoes in World War II, and essentially became one of the fathers of the lunar module. He worked for NASA, and he worked with another fellow called Tom Kelly, who managed the lunar module program at a company called Grumman Aerospace. And here are the two of them sitting just off in a room off of mission control during the Apollo 11 mission. So these two guys are considered to be the fathers of the lunar module. And as a result, Apollo 11 successfully landed, and 5 other missions landed safely on the moon. So we just had the 50th anniversary a couple of years ago, and Canada Post put out a stamp, but also reminded us that a company in Longueuil, Quebec called Hera, it's called Hera DevTech now, was responsible for building the legs of the lunar module, not the foot pads, but the legs and the supporting structure. So Canada had many various parts, contributed to many of the parts of that program. And in the little Canada Post write-up that came with the stamps, there was a write-up on James Chamberlain and Owen Maynard, two people who came from the Avro Arrow program and contributed to the American manned space program. So after Apollo came the Space Shuttle, and Canada was involved and continued to be part of the American space program, and contributed the first Canadarm, which was built not very far away from where I am right now, in Etobicoke, and by a company called Spar Aerospace. As well, we were given seats on shuttle missions, and so the National Research Council went out to hire some people to be our astronauts. And I'm sorry to say that one of them, Bjarni Tryggvason, the fellow at the back on the right, just passed away a few weeks ago. So we were sorry to hear that. So the first Canadarm flew on Columbia on the second shuttle mission, and it has been a workhorse ever since. Our first astronaut flew on mission 41G. You might ask, well, why did STS-2 become 41G, the 13th mission? And well, NASA got a little superstitious, and after the 9th mission, they started using this strange naming convention, just so I think they wouldn't have an STS-13. But one of those astronauts was Marc Garneau, and that's a picture I took of Marc just before he got on the Astrovan to go out to the launch pad that early morning in October 1984. And there we are standing. We put up a Canadian flag by the water, and you see Challenger in the distance there. So this is another piece of art by our good friend Paul Field, depicting not only the launch and our little flag there at the bottom, but also the shuttle Challenger in space and the arm. So that was quite a great mission. Since then, we have other astronauts who traveled into space and used the arm, like Chris Hadfield when he visited the Mir space station. And I said a workhorse. The Canadarm just was it. I don't know how they could the shuttle program would have had any kind of success without the arm. Not only positioning spacewalking astronauts during spacewalks, or just grabbing satellites like this huge Hubble Space Telescope, placing it in the payload bay so that it could be worked on, or just there were various things that they did with the arm that they didn't plan. In fact, on one mission, the mission before Garneau's mission, they had a problem with the device that they used to essentially jettison P into space. I can't word it any different way. And there's a little way that urine is collected on the shuttle, then it's shot out the side of the shuttle. And what happened is it kind of got clogged there, and ice began to build up, such as there was a big icicle, or you would call it a urinicicle, I guess, or something like that. But anyway, they didn't plan, but they figured out how to use the arm to actually move it around the side of the shuttle and knock off that piece of ice to so that it didn't hit the shuttle during re-entry. So another thank you very much, Canada, for the arm moment. And that gives you an idea of the size of Hubble. That's the engineering model that was in the Air and Space Museum. I'm not sure it's there still now, but actually Chris and I were there at the same time at a conference and came upon this huge telescope that I both think we'd all like to have in our backyards. So the space station was the next project to follow the shuttle, and Canada was involved, and we contributed our arm, the Canadarm II, the space station arm, and hired some more astronauts. And currently, these are the 4 astronauts who are current astronauts right now: Jeremy Hansen, and Dave Saint-Jacques at the top. David has been to the space station. Jeremy is due to go to the space station at some point. And our newer astronauts, Joshua Kuttrick and Jenny Seide. So going to the space station meant Canadians would participate walking in space. And Chris Hadfield's mission, they actually deployed the Canadarm II on the space station. And here's another Paul Field depiction of what that would look like. It would sit on this base that would then move along the spine of the space station, and then the arm could take pieces out of the brought up by the space shuttle, and then essentially build the space station like a big Tinker Toy set. And there's the base of the arm, having the arm just taking it out of the a space shuttle and putting it on the space station. And then you see the various points where the arm can attach itself. And essentially it can crawl all over the space station using this device. Dexter is essentially a little robotic hand or series of hands that fits on the end of the arm. And this has allowed mission controllers in Houston and in Saint Hubert to actually do work outside the space station, not requiring astronauts to do a spacewalk. So it's been very useful there. And there's Dexter sitting on the outside of the space station. After the Columbia accident, there was a requirement to be able to observe the heat protection system on the shuttle after it gets into orbit. And McDonald Detweiler here in Brampton actually developed another arm that the shuttle would then use, and essentially with sensors on the end of it, observe and scan all of the heat tiles on the base just to make sure that the shuttle was safe to re-enter. And that's how that looked. So we had astronauts on the space station. Here's Bob Thirsk and Julie Payette, who were up on a, Bob was up there for several months and Julie was just up on a 2-week space shuttle mission. But we had 2 Canadians on orbit at once. And Chris, of course, had his guitar and his David Bowie video, and was up there as a commander of the space station. And David St. Jacques was the last Canadian to be up on the space station. And something that really irks my American friends, and that is we put our space stuff on our money. And I always enjoy handing out $5 bills when I go down to space conferences to bug our American friends. So that's where we are right now. Now, what is coming up next? Well, we are going to the moon. And the name of the project is called Artemis. And in mythology, Artemis is the twin sister of Apollo. So this seems to be an appropriate thing to call our project to return to the moon. It will involve building a small space station in lunar orbit called the Lunar Gateway, which will be used as a sort of a waypoint for astronauts coming to go to the lunar surface. They'll first go to the Lunar Gateway. It will be a science post, and ultimately, there are ways that this could potentially be our first step to go beyond the moon and maybe off to Mars. But that's a little ways ahead of ourselves right now. Why go back to the moon? Well, it is time to return, to learn about how to live off of the Earth. And have that capability. There's a lot of science to do on the moon. We only had 6 missions, landing missions in the 60s and in the 3 years when we were running the Apollo programs, and only spent essentially in total a couple of weeks on the moon. So it's time to go back and do the science and learn how to live off of the planet, and ultimately become a planet-faring, spacefaring species. So that is why we're going. So this is the Artemis program. And there is something called the Artemis Accords, which is essentially an agreement that international space agencies have signed to come on board the Artemis program, and essentially to agree to the various parts of the agreement. But the main thing is to work together to peacefully explore the moon. So there are 3 missions now planned. That doesn't mean that there are only going to be 3 missions, but these are the first 3 missions planned for the next few years. Artemis I is going to launch sometime this year. It will be uncrewed and it will go to the moon. Artemis II will carry the first crew, and it will be essentially a similar flight to Artemis I, that is going out to the moon, being in orbit around the moon for a while and coming back. And the plan is to land astronauts on the moon on Artemis III. Specifically, the plan is to land a female astronaut and an astronaut of color on the moon. That is NASA's plan at this point. So here's a very detailed depiction of the Artemis I mission. They will launch an Orion spacecraft on an SLS rocket booster, Space Launch System rocket booster, and it could land. The capability of the Orion with its service module it's quite more capable than Apollo. Apollo was very heavy and it had a very specific mission. This is more of it looks to me more of a sports car type spacecraft that can go into various orbits around the moon and be out there for a couple weeks before coming back to Earth. So the SLS, just the first one, went out to the launch pad a few weeks ago, and this is a picture that Ben Cooper took that I really like, sort of showing the target in the distance there. So this the SLS rocket is they are reusing space shuttle technology. The large orange tank from the shuttle has been increased in size, and that they're using similar solid rocket boosters to the shuttle. They just have increased the length a little bit. So this rocket is now on the launch pad. They've been going through a series of tests where they load up the rocket with cryogenic fuel. They've been having some troubles. There were troubles when they did this with the Saturn V back in 1967 for the first time, but they were hoping that they could solve their problems and have a launch sometime this summer. Just before this meeting, they announced that they're actually going to have to roll the entire stack back to the hangar and fix some problems and most likely roll back out again and conclude their testing. So that would push the launch probably to, it's delayed. So I would think late summer, early autumn for the Artemis I. And of course that would push Artemis II and Artemis III out somewhat. But there it is sitting on the pad, about as big as the Saturn V Apollo rocket. And so I found these pretty pictures that I would share with you. So there's the Space Launch System and the Orion crew module on top, with room for 4 people. Apollo had 3. And that is what it will look like when it's on the way to the moon. So the Artemis is not designed to carry the Lunar Lander as well, like Apollo did. The Lunar Lander will make its way out to the moon on its own. So here's Artemis II. And again, it's going to be crewed. And the exciting part of this is one of the seats will have a Canadian astronaut. And the crew selection is supposed to be sometime this year. So that's great to be part of this mission and have one of our 4 astronauts to be on this trip. I don't know who it's going to be, but well, it's Jeremy's turn to fly. So hopefully we'll get the good news soon. So here are the 4 astronauts the 4 candidates, and one of them will be on Artemis II. The other promise that NASA has given to us for our participation in Artemis is that another Canadian astronaut at some point will be going to the Lunar Gateway, the space station going around the moon. No word yet as to when a Canadian astronaut could be on the moon, but I think it's just a matter of time that as the more and more flights take place and more people, as the base on the moon, as they envision what they want to have takes place, then we'll see a Canadian on the lunar surface, which of course will be excellent. So Artemis III is the first landing attempt, and as you say, it looks pretty complex, primarily because the Lunar Gateway won't be built by then. So we'll have to wait and see if get more more details on how Artemis III is going to take place. So there are the 3 components: the gateway, space station, the landing system to get astronauts down to the surface and back up to the gateway, and then ultimately a base camp. And the plan is to to set up a base on the moon near the Shackleton crater near the South Pole, where we believe, or where scientists craters, which would then have water ice, which could be actually retrieved and used, because water is very heavy, a very heavy thing to lug around. Anyone who's bought a package of a dozen water bottles at the grocery store knows that water is very heavy. And so if you can mine water on the moon or Mars or wherever you're going, that would be a big help. So the plan now is for SpaceX to develop a lunar lander similar to their Starship. I haven't seen any drawings apart from this depicting the lunar lander, but it looks so 1950s-ish, where they're landing an Atlas missile on the moon, and you have to climb out of the little cabin at the very top and somehow climb down a knotted rope or something to go to the surface. So, but anyway, it looks like they're even thought about ways to lower moon rovers or other payloads down to the lunar surface. So we'll look for more details there. And as I mentioned, the Lunar Gateway formation expected to start in 2024. Well, we'll see. These dates tend to be pushed out as we go along. But you see, it's a very complex space station, multi-modules built by, at this point, various space agencies and companies. So that's something to look forward to. So Canada is participating by sending people to the moon, but also we have programs where Canadian scientific companies and organizations will be able to do science on the moon, which is going to be exciting. Yeah, so that gives you an idea of what the Canadarm 3 is going to do. There's a lot of artificial plans for artificial intelligence to be incorporated into the arm. Finally, just to finish up, there's a program called LEAP, which is a program where the CSA is going to be providing funds for various scientific organizations to develop technology and experiments for testing out in the lunar environment. There's also a program to essentially develop capability to, I guess, provide healthcare to astronauts when they're far away from the Earth. So that's what the Health Beyond initiative is, because and it's something that they would apply to also, how do we provide healthcare to people living in communities that are remote here on Earth. So that's another program the CSA is developing. They're looking at developing a lunar rover for the lunar surface. Again, that would be to explore the South Pole and look for signs of water ice. There's also a plan and it's something that's going on right now, this Narvik project in Nunavut, which is developing food in a remote site. And what is learned here will be used to develop and grow food on say, the moon. so that is my talk, and I hope this gives you a good background on where we've been and where we're going.
Thank you so much, Randy. Wow. I want to ask whether or not there's questions that anybody has, to put them in the chat, and also anybody on YouTube right now, if they would like to put those on, put those in, then we can be looking to answer any of those. I have a first question, Randy. How are the Artemis Accords doing? Was Russia part of any of this at all, at any time?
I don't believe they are. They haven't signed the Artemis Accords. Okay. And at this point, I think, well, who knows what will happen in the future, but yeah, they're not part of the Accords. Various space agencies from smaller countries have been signing up. I think New Zealand and Finland, for example, who don't have huge space programs, but they have space programs. And so I think we realized that to go out into space and out into the solar system, it would have to be an international venture, and Canada is right in there.
Okay. Peter Jedicke has asked, does this Orion capsule go right down to the surface, or is there a new version of the LM?
Yeah, Peter, there is a new version of the LEM, and that was the SpaceX Starship that I showed there. They have the contract to build that. I haven't seen a lot or heard a lot about that. And what's interesting is, there have been plans to say, okay, well, we're going to do Artemis II in 2024 and Artemis III a few years after that, but it takes a while to develop these things. So, we'll just have to see how long it takes. It was delayed for a while because Blue Origin, another company, wanted to essentially build the lander, and there was a bit of a legal battle there, and it was kind of messy. But at this point, SpaceX is going to be building the lander. And so it'll essentially, the astronauts will go to the, ultimately go to the Lunar Gateway and then get into the lander and go to the lander and come back up, and kind of like 2001: A Space Odyssey, but from lunar orbit, not Earth orbit. Another question, will lunar rock samples be returned to Earth? I'm sure they will. That's one, and actually the Orion is reusable too. So I'm sure that there will be a steady stream of supplies going out to the moon, and scientific experiments coming back to Earth.
Randy, we have a question from YouTube, and the question is, would you be willing to hazard a guess as to the year that Canadians will walk on the moon?
No, I would not. Primarily because they've only announced the first 3 Artemis missions, and I think a lot of the success of the Artemis program will be dependent on budgets, and the Artemis has actually been delayed because of budget cuts and technical problems and whatever. It's just too difficult to say. Even if there was a plan to say a Canadian astronaut would be on the 6th mission or something, there's no way to predict when the 6th mission would be, because this is a developmental program, and you've got to get through the first 3 missions at least to get an idea of how long it will take to. And it takes a while to build these SLS rockets. I mean, there were plans to maybe build one a year, so that's pushing it out to the future sometime. So I wish I could help you there, but.
Does anybody have anything else here? Oh my gosh. I'm wondering whether or not, Randy, if NASA can take a little bit of some knowledge and know-how from what happened with the JWST and how long it was delayed? Or is that a completely different problem?
There were budget problems with James Webb as well. And I guess, Chris, if you can chime in and help me with this, I think there were 3 problems with James Webb: budget, technical issues, and even some management issues that they had to deal with. So yeah, there's it's interesting, the idea of why are we going back to the moon? It's been 50 years, and it's anyone who remembers the moon landing. It was like, oh, we've been to the moon, and 20 years from now we're going to be to Mars. And I keep telling people that there's this carrot with the stick with a carrot on the end, and it's a 20-year stick, and that is how long it's going to take to get to Mars. But this stick, everyone's still carrying around this stick, and it's always been 20 years. And just the other day, I saw something from the NASA administrator, and he said, yeah, we're going to get to Mars in 2040. Well, that's another 20 years. So, there is no real rush to spend this money, unfortunately, to put people on the moon or out to Mars, I'm afraid. There are other priorities. And, I think, you look at the billionaires in space, the reason that there are billionaires in space is because people like Elon Musk want to go to Mars, and they aren't willing to wait for NASA to do it because he'll be dead. So he's got his money. He's building a system to go to Mars because he wants to go, and he wants to go in his lifetime, kind of thing.
Yeah.
That's my take on it. I mean, people could argue like you're crazy, you don't know what you're talking about, but it just seems to me that there's no rush to do these things.
Well, it has to be done right, because if anything happens to any of these missions, then you can be darn sure that they're not going to start spending another, hugely $1 billion if they haven't got it right. So.
Yeah, and well, this big rocket, this SLS rocket, I think someone came up with the idea that it's like $4.5 billion each to fly. Well, that's, the people in the government have said that's not practical. That's not attainable. Right. So something's going to happen dramatically, I'm afraid.
Randy, I have another question for you from YouTube. And the question is there any controversy over the vertical design of the SpaceX lander? It doesn't seem to work well if people have to get down from the top.
That was my reaction too. I mentioned that it looks like the 1950s designs of, space rockets landing on the moon, where, astronauts sort of climbing out and climbing down rope ladders or something like that. It's there, and I guess to answer the question, there hasn't been a lot available in designs or explanations as to how, that to me looks like you need a very, very smooth landing site. You don't want to hit a rock, because those things look just so tippable. Yeah, it's very, very interesting.
It would be, watch out for that first step for any astronauts on there.
Oh, exactly. It's so funny though, because some of the early Apollo lunar modules didn't have a ladder going down the front leg. They actually had a knotted rope. So I always wanted to ask somebody back from, in the early 60s, where did NASA get their knotted ropes for the Apollo lunar module? And then they figured out, no, there's no way that's going to work. So we're going to have to put a ladder on the front landing gear. That worked out a lot better.
In the movie The Martian, right, they had a ramp that came down out of the bottom, and that's how the astronauts exited. So maybe there's something, I don't know. That was The Martian had it right.
Well, except that's where all the rockets are. So I don't how big the living space is, and it looked like they were in that picture. They were just they had these little platforms that were just sort of lowering payloads down. So maybe there's a little cage that you sort of get in and go down, something out of Robinson Crusoe or something.
So Randy, that maybe this last question, or do you have something else, Amy? Do you have anybody
No,
else on?
I was also looking at that last question. So you can-
Okay, so let's do this. Is there enough funding to do the Artemis missions?
That's a good question. I mean, there are going to have to be a lot more than 3 missions to put a lunar base on the moon. Right now, the 3 missions just get 2 people to the moon for, I think they're supposed to be on the moon for a week or something. That's a very good question. And we'll see.
Maybe another time we can have a really good debate about, about spending the money. Because I'm sure we could get people on both sides of that issue without any trouble at all.
Oh, for sure.
Yeah.
For sure.
Thank you so much, Randy. I really appreciate you coming on board with us this evening. You are very welcome to stay with us. We've got some more things happening, but we also realize that it's getting a little later there. And if you'd like to if you've got better skies, then you might want to go out. But we're really happy to have
I'll
you
take a
here.
look.
Thank you so much tonight.
Thanks,
Randy.
everybody.
It's
My pleasure.
appreciation. Okay.
You bet.
All right, I'm going to turn it over to Amy because she has got some special stuff here for us. Oh my gosh, Amy! Wow.
I have this box that goodies that we're ready to give away. So a number of you have participated and shared some images or drawings of the moon over the last number of weeks, with the theme of the moon, where we thought we would do a little bit of a giveaway. So this is what we're giving away. one of the little buddies, of course, the moon. We have a Galileoscope, some lunar themed jewelry here. There is socks, and we've got a couple, an astrophotography book, of course, and the Discover the Moon book that we sell in the gift shop as well. We have a moon-themed eye mask made by one of our volunteers, and we have a card. We have magnets. We have some glow-in-the-dark stars. There's a few goodies in this box for whoever wins it. But I'm just going to take a second to mention that right now, in the gift shop, all of these items are available. So if you are interested in acquiring some lunar goodies for yourself, all of these things are available for purchase through our website. The link is in the drop down, I think, Calvin, or I think it's on the top that you can get to our gift shop.
Yeah, I can.
And now I'm going to attempt
to
to share my screen. Let's see. All right, so if this is working, you're seeing this go round. So we're going to spin. We're going to see who our winner is. Sticked over. Okay. So our winner is Bill is the name of our winner. And I have another. Sorry. So I wanted to share also with you guys some of the images we got. So I happen to know that Bill had already emailed when the images were sent to say that Bill wouldn't be able to attend tonight's star party. So I'll be notifying via email. But I want to show you all some of the images that we received over this time. They're stunning and not all taken through a telescope, not all taken with a camera. And if you've taken an image of the moon through a telescope, it is not easy. So of course, I am looking forward to the section, with David and Nathan, where they tell us a little bit about the tips and tricks for how to do it, because it's not easy. So, so here are just some of the images. Obviously, some people are a little bit more versed in doing this through telescope than I am. This is a drawing, and this is a drawing, if I remember the description right, as to how it would have been seen through a Galileo scope, which is in the prize pack. But also, I think the next one is an image of what the Galileo scope that would have been looking at the moon, what it might, what it would have could have looked like, right? And you. There's some pretty great ones. Like, yeah, and that brings us to the end of the, the images that we've got. So thank you guys so much for participating, and congratulations to Bill, of course. And this was a lot of fun. So we're going to decide on another way and another theme for a different giveaway and give people a chance to win another prize pack filled with goodies. So look out for that probably in the coming months. And like I said, if you're interested in purchasing anything from the gift shop, please do so. If you are a member, check your newsletter, because there are some perks for the members in terms of discounts available to you. And now, after looking at these pictures of the moon, I am happy to introduce David, who we are not strangers to at all. David usually runs the EAA portion of the Star Party. And David is going to tell us a little bit about how to take a picture. I was going to include one of my pictures, but it's really more a picture of the inside of a telescope than of the moon. So David, can you tell us
That's a start.
about that?
Well, thank you, Amy, and good evening to everybody. I want you to know that I have a co-presenter with me, and that's Nathan. If somebody could spotlight Nathan, that would be great. There you go. Hi, Nathan. So I'm going to sort of take you through some of the interesting features about the moon that you can photograph, and then we'll talk a little bit about technique. So as Amy says, there's all sorts of different devices that can be used to take pictures of the moon. So I'll just start my presentation. Okay, so basically, there's lots of different ways of taking pictures of the moon, and I'm just going to go over some of the special conditions, some of the interesting conditions that we can find the moon in. So you can see there's certainly different phases of the moon that you could photograph under, and if you had access to this diagram, you would have been able to answer one of those questions that we had earlier on. And here's that waxing crescent that follows the new moon here. So yeah, there's lots of situations. You can certainly not get bored photographing the moon. There's lots of conditions under which we see it. So one of the things, it's a very favorite subject for astrophotographers, like people that are just starting to photograph astronomical objects. One of the reasons is that it's relatively easy to find, and it's relatively bright, and it certainly has lots of opportunities to be photographed well. So if you're using an image of the moon that's of any size, like if you're using a telescope or using a very long telephoto, one of the best areas to focus on is something called the terminator. And that's where the darkness meets the light in the moon. So we can follow that along in the different phases, and this will move along and definitely highlight the features along the edge. So any crater that is aligned to the terminator will be much more pronounced and will look quite different. So as the terminator is approaching an area, it may look very flat, but then as the terminator approaches, it would actually increase in contrast and sharpness. So another situation that exists is atmospheric effects, and this is one of my favorite. I often, in my planning, when I look at opportunities to photograph the moon, I'll look for moon rises, because often what happens is that when the moon rises from the horizon line, the turbulence, the atmospheric turbulence is much higher near the horizon line. So often, now you can't see it here, but you can start to see shearing in the edge of the moon, and you get much more pronounced color at the same time as well. But I've actually seen this where the moon actually separates. So in other words, you can see the top half and the bottom half, and the whole middle section's missing. Kind of looks like I won't say a cheeseburger. It kind of, there's that missing piece in the middle, and that's just because of the diffraction. Very cool. So the other thing that is a favorite of mine is photographing the moon so you can see different parts of it, because often when we look, the contrast is so extreme that we will not see the dark part of the moon. So it's quite challenging, but it's always an interesting image to be able to capture like a crescent, not necessarily a super thin crescent, but a crescent maybe 2 to 3 days old, and then also be able to capture the earth shine. Now, earth shine is the light that's reflected off the earth back onto the moon. So it's unique in that sense. So the best time, as I say, is when the crescent isn't too big. Once the crescent gets too big, then it's really hard to have a good exposure for the crescent and for the earth shine, the darker part. So here's a challenge for you. There are unusually thin crescents. So when you're coming from the thin moon, from the new moon, it's always a challenge to find the youngest moon. They call it the young moon. And I've never been able to do better than about a day or so. But some people cite them around maybe half a day or something like that. It really depends on orientation. Now, they will always occur either at dusk or at dawn. So I think the only occurrences I've had are ones that are at twilight. And this one's at twilight, for instance. And you can see it comes quite close to the horizon line. But a very cool thing to try to photograph. Another thing is eclipses, lunar eclipses. That's an opportunity for us to see sort of light come to play on the surface of the moon. So when the moon is eclipsed, it will often take on this kind of orangey red glow. The last couple of times I've photographed it, I've started noticing in the upper edges of these eclipses, sometimes like a teal color. It's not very pronounced here, but in some of my images, I've noticed a teal color, and I often thought they were like defects, but in actual fact, they're not. So it is really a characteristic of this eclipse. So the other thing that I'm really fond of is lunar conjunctions, and here you see Earth shine here as well, but there's lots of opportunities when the moon is aligned with other bright objects, and this is a situation. I remember driving downtown, I think at maybe 3:30 in the morning or something like that, to head down to Dallas Road, because Dallas Road was going to give me that really low horizon view that I needed. And I remember waiting there with, I think with Randy. I think I waited with Randy and maybe Alex, waiting for the clouds to part. And
I was there with you.
Yeah, waiting for do you remember that, right? We were waiting for the clouds to part, and it did eventually part. So one of my favorite pictures. But these kind of conjunctions happen from time to time, so they're great photo ops. So photographic technique, you can use digital SLR with a long lens. You can use a point and shoot, and you can even use a cell phone. Now, I'm not much of a cell phone user, and that's why Nathan's here to sort of give us an idea of what to do with cell phones. I'm too old for that, so I know how to do the other stuff, but I don't know how to do the cell phone stuff. So one thing about lunar photography is you will more than likely want to use a manual type of exposure. You probably will not want to do auto, because either the moon won't occupy enough of the area that you're photographing, or it might be so bright. Now remember, the moon is actually reflecting sunlight, so it's extremely bright. And when you photograph something with a camera that is extremely bright, it will turn out darker. And the reason why is every meter in a camera is designed to produce neutral gray. So if you were to image a white wall, it will turn out neutral gray. So as photographers, experienced photographers, we often overcompensate. We often add more exposure so it comes out the right tone. So we've got this, what we call the exposure triangle. You've got the sensitivity of the sensor, the shutter speed, and the aperture. So those three elements form the exposure. And you have to use this triangle to sort of manipulate the exposure. I'll tell you, the other thing is, I mentioned this already about the dynamic range of the moon, how the brightest part and the darkest parts are very, very extreme. And they can be as much as 7 stops of exposure. It probably won't mean that much to non-photographers, but it's quite broad. It's not easy for most sensors to achieve a good reading, unless you're using one of the newer sensors where you're actually using a raw format, where you might approach getting like a 7-stop range. Now, one thing that most people are surprised by is that the exposure for a moonshot is actually almost daylight exposure. And what I mean by that is, if you were to take a picture during daylight and noted the exposure, that would more than likely be very close to the exposure you would need to use for the moon. And the reason for that is it is lit by the sun. So I find that most people find that very surprising, but really it is daylight exposure. And I also include this kind of rule of thumb. When we started, this is in the old days, when we started as photographers, we would remember this sunny day exposure. So 1 over the ISO, or the sensitivity of the film in those days, using that as a shutter speed at f/16. And that's a starting point. Now, this will vary somewhat. If it's cloudy, it's going to change a little bit. The elevation of the moon's going to make a difference, and also the phase, like how much of it's truly lit. So that's probably kind of obvious, but exposures will vary, and that's where you want to take probably several exposures. So the other thing is getting critical focus. Now, in the old days, lenses would have an infinity setting. Autofocus, again, isn't necessarily the best thing to do when we use a camera, because sometimes it won't be pointed at the right place. Or for instance, if your moon is offset and you're pointing somewhere else, it won't necessarily, unless it's an infinite distance away, it won't necessarily be the right focus. So I always recommend, again, go manual if you can, and then try to find a bright star and try to focus on that. And the trick with the bright star is make it as small as possible. Usually when something is big, like a star, it's supposed to be a pinpoint, right? So if it's big, that's probably out of focus. So we always kind of use that as a guide. Some new cameras actually have something called live view. It's kind of like a video mode for the camera. You can certainly turn that on, and then even magnify that point to make that star as small as possible for critical focus. So the other thing is, as your exposures start to get a little bit darker, if you're photographing eclipses or you're trying to catch Earthshine, you may find that you can't any longer hand hold the exposure. And that's where tripods come into play. You can sort of experiment a little bit. I mean, this is one of the things with the moon. It's typically a willing subject, so you can sort of practice and see if our exposures are in line, like if your shutter speeds are fast enough to overcome any movement that you might have when you're holding your camera. So tripod, highly recommended. A lot of cameras nowadays have vibration reduction. You can take advantage of that as well. Often I think people have been able to take pictures without tripods just because the vibration reduction that's built into the lens is sufficient to allow you to have a fast enough, or the fast enough shutter speed is compensated by the vibration reduction. So the other thing is the focal length of your optics is going to determine the size of the moon. So there's lots of formulas you can use to determine how big the moon will occupy in your frame. But I find that the best thing to do is actually use a program called Stellarium, which is free. You can use Stellarium and then define these fields of view based on your lens and based on your camera. And then you can see how much of the frame it's going to occupy. So that's what I've done here. I'm showing you a frame from Stellarium where you can actually do that. So I don't know, maybe Calvin, maybe you can throw up maybe the URL to Stellarium for the folks in the
Already on
audience.
it, yeah.
Oh, excellent. Thank you very much. So the other thing is, as you vary the focal length of the optics, the image becomes bigger and bigger. So, now we're into the realm where you're no longer using photographic lenses. Now we're into the realm of telescopes. So for telescopes, there are two main ways. And the first one I want to talk about is called prime focus. So basically, if you have a camera, a lot of cameras nowadays will allow you to remove the lens. So you actually see here's a camera body, but it has no lens. You often need a prime focus adapter. It's typically just a tube and a way of attaching it to the camera body. And that usually goes into a telescope. Now, this is an example of a refractor. Now, normally the refractor would have a diagonal on it and have an eyepiece on it in order for you to look at things. But this whole piece typically comes off, and then this tube goes into its place. So now the refractor becomes like a giant telescope or a giant photographic lens or a telephoto. So outside of that, everything else is the same. The exposure mechanisms are the same. With the longer focal length, you would typically need either faster ISO or higher shutter speeds to compensate for any vibration that's involved. So the very next thing is, Nathan, do you have slides, or are you going to do a live demo?
I have slides.
Okay, so I'm just going to do a quick forward here, and then I'm going to stop sharing and allow Nathan to share. So this is called afocal photography. So rather than prime photography, prime focus, this is called afocal. And this is based on the premise that if you had a camera or a recording device that typically focuses at infinity, if you were able to put that into the eyepiece of a telescope, you can probably record the what your eye would have seen. So your eye was kind of like at infinity looking through the eyepiece. Instead, you move your eye away and you put a device like a cell phone, and then put it in its place over the eyepiece. Now, there's lots of different ways of doing that. There's kind of fancy ways of doing it. This is a product made by Celestron, and it allows you to position the cell phone camera over the eyepiece. Now, I'm sure Nathan probably has his own tricks, so I'm waiting to hear him share that, because I doubt if he uses something like this. So anyways, I'm going to stop sharing, and Nathan, tell us your tricks.
Okay, thank you. Okay, so this is just a quick guide to doing iPhone astrophotography. And, you know, it is probably the lowest level, but, you know, it's been serving me well for 4 years. So really, it's an interesting process, because the way I do it doesn't require any mounts or doesn't require much focusing or any like way of attaching it to the eyepiece at all. So I can show it just in a guide with several steps. So the first step to doing this is to hold the phone up to the eyepiece, sort of like this. That actually is the only step. So if you can just see my camera here, I can just demonstrate that. You have the eyepiece, and then straight through the eyepiece, the phone goes. That's it.
Okay.
But there are some other things to take into account when you're doing that. The first one is that for some eyepieces, the hole is very small, the visual hole, and so it's necessary to just kind of wiggle it around a bit at first until you get that point of light that comes through. And I find sometimes it's really hard to like, if you're hovering the phone above the eyepiece, it's hard to hold it in place because people's hands are shaky. So I find it's helpful to press up the eyepiece against often eyepieces have like a rubber ring around the edge. So it's helpful to press the phone's camera up against that so it doesn't wobble around as much. Oh yeah, did you like the 2001: A Space Odyssey reference?
Yes. Nathan, okay, let's say you're using an iPhone, for instance. The camera is kind of offset off to the corner. How do you know how to aim the camera into the eyepiece? Just purely by whether you see anything or not?
Well, often when I'm lining it up, I have the camera view open, and it's really just a matter of trial and error for the first few seconds because you're just kind of moving it around until you see that flash of light. The moon, it's particularly easy with the moon because it's so bright, so it's really obvious
Right.
when you found it. For the fainter objects like Uranus or Neptune, it takes a lot of time to find it. And that's why the iPhone mounts can be nice, which I'm going to talk about in a moment. There are specialized iPhone holders that can basically grip the eyepiece in this middle section here, and then hold the iPhone in this section here. It does take a little bit more setting up than just holding it up to the eyepiece, but it can be worth it in a lot of circumstances.
So which do you prefer for the moon? Just freehand?
For the moon, I definitely prefer just holding it handheld.
Okay.
For other objects like things that you need two hands for, these holders are better. And they also can help in getting a more consistent image. If that's what you're looking for, these iPhone holders are pretty good.
So I'm assuming you have to be pretty careful keeping it square to the eyepiece as well, and not tilted, right?
Oh yeah. Well, there's no up or down in space, so you can really take a picture at any angle. But yeah, I suppose if it moves around too much, like I mentioned, that field of view is pretty small, so it does take a bit of precision, which is again why these iPhone holders can be really nice. The other really important thing I wanted to talk about is the number of lenses that the phone has, because like I said, that window of light from the eyepiece is pretty small. And on these newer phones that have like multiple lenses, the distance between those lenses is much larger than the size of that window in the eyepiece. So I'm not really familiar with multi-lens phones because I've never used one for iPhone astrophotography. I don't know if there's a way to disable one of the lenses, but anyhow, only one lens should be active. Otherwise, one of them is not even going to be looking through the eyepiece. And then another thing is no matter how many lenses phones have, they can often automatically focus on whatever you're looking at to a certain extent. I'm sure that these fancy cameras can do it better, but iPhones are decent at it as well. Another really important thing that I can't stress enough is to avoid the astronomical phenomenon known as, oh shoot, I left the flash on. It's really pretty, but it's not going to help you capture anything. So yeah. So often for phones especially, the moon can just be too bright to capture any detail. And in that case, well, first of all, you can just try dimming with this brightness dial. I think, I mean, if you tap what you're focusing on, which in this case is the moon, it'll give you like this brightness dial thing. And I think most phones come with just a way to adjust the brightness. However, sometimes even the lowest brightness or the lowest exposure in that case is still not enough. The moon is still going to be too bright. And in that case, it may be necessary to get a light reduction filter. That's just a filter to put on the eyepiece that doesn't have any color or anything. It's just gray, and it just lets less light through.
Probably like a lunar or a neutral density filter.
Exactly. A neutral density filter is is ideal for this. However, yes, sometimes the iPhone itself can just automatically adapt to it. But yeah, sometimes a neutral density filter will be necessary. And then the last thing I wanted to talk about was just sometimes there's a lot of contrast between the details you want to see. Like in this, I took pictures from the lunar eclipse way back in 2019, I think. That was before the pandemic. That's weird. Anyway, so during a lunar eclipse, there's two very nice details. One is in the shadow, which is dim and red, and the other is illuminated, which is very bright. And usually iPhones can't capture both of those in one image. And same goes for what you were talking about earlier with the Earth shine. However, I'm hesitant to call it HDR because that implies a lot of fanciness to it, and this is not fancy at all. But there's a very quick way to, a method that I use to incorporate both of these, which is just to create 2 copies of the image and then make one of them transparent and then just move the transparent one over top. I mean, this is like really straightforward. You could do this in Microsoft Word if you wanted. And then this was the image that I got for that. It's not really HDR, but it's something. And
yeah, I think it's actually not an uncommon technique, actually, even in film days, to just take different exposures and integrate them. That's what you're doing.
And I'm sure that the stacking programs out there can do a much better job than Microsoft Word, but I've been happy with it. And yeah.
I have to say, Nathan, all your work has been extremely impressive based on what you're using.
Thank you. So yeah, I'm happy to answer questions.
Yeah, Nathan, are you using a special camera app or just the camera app that comes with the phone?
It's just the default app.
Okay.
Yeah.
Okay. Interesting. Okay. Well, thanks, Nathan. I'm just going to switch back to mine, and then we're going to entertain whatever questions we might have.
Okay.
Okay.
So if anybody has any questions for David or Nathan, please, you can put them in the chat, or for those of you on the Zoom, you can just put your hand up in the reaction section, and we can get to you.
Sorry, Lori. I'm just going to put up some resources here. So if you guys want to kind of screen cap what's here, these are good references to techniques for special conditions or special situations. And you can always ask for these as well. I'm going to leave them with the people here at the desk. And if you're curious about them, great.
So I wanted to say that I bought an XYZ, which is kind of a little bit of a fancier, more complicated system for using your iPhone. And I went out on one of the nights when we actually were able to get a little bit of some clear skies. It wasn't very many, but I did go out, and I'd never used it before. And I got exactly what Nathan showed, was this like bright kind of part, and then like nothing on the other side. And I couldn't get the camera to compensate for those, for that at all. And I got cold and went inside. So that I'll now kind of work a little bit with trying to put all of that together. I think that would be a really good thing to try. I will try. Okay. And I will see what I can do. I actually gave Amy what I would call a before the talk photograph. This is what you should not do, to take a picture of the moon with your iPhone, but she declined to put it up, which was a good thing. So, yeah.
Okay.
All right. Is there anyone that has any other questions for David or Nathan? And Calvin, you're looking on the people on YouTube?
I am keeping an eye out for the people on YouTube as well,
Yep.
if there's any questions. And while we're waiting for any of those, I did just want to sort of share a quick story of like my short attempt to like do some kind of astrophotography in the similar way that Nathan mentioned. Um, I actually, what I wanted to do, so I had like the kind of telescope that's like more for bird watching, very simple telescope, and I got a webcam plugged into a Raspberry Pi, and then I was trying to attach the webcam, this little thing, onto the eyepiece. But then there were some tutorials I saw that actually mentioned taking the eyepiece off and then also taking like the lens off of the webcam so that it just the main lens of the telescope is focusing down. But any attempt that I did, like I couldn't get it to like sit right, and I'd have to probably build some sort of mount thing that to fit it on. So that project kind of petered out. But that was my attempt. Yeah.
There you go. No, it's interesting what people try, and it doesn't hurt. It's just your time, right? Just experiment a little bit and see what you can do.
Yeah. Thank you, David and Nathan, for giving us your experience and your expertise in what is happening, and we hope that we'll continue up at the Hill, maybe in person or hybrid models or something like that we can keep going. So I'm going to switch over a little bit, and we're going to get to our next person that we have, that is one of our people within the RASC here in Victoria, that has a passion for the moon almost beyond anybody that I have ever known, and he does a huge amount of sketching, and I'm hoping maybe he might kind of actually, maybe put up some of his sketches. I'm not sure whether you've got those there, Randy, but he does some beautiful sketches of the moon as well. So I call him our resident selenophile, which is a person who is very fond of the moon, and that is Randy to a T. So I'm going to add to move over into our ask a selenophile. Any questions at all that you have on the moon, anything at all, then please just, Randy's here to help us out tonight. And we'd love if everybody could come up with, one good question to ask Randy about the moon. He knows it all. All right. So we will check on both the chat and on YouTube. So just you can throw your questions in there.
Talk and show off some things until you start asking me questions. But this was from yesterday morning. I have this thing. I just love sketching in the middle of the night. If I'm up at 11 or so, I'm just falling asleep. But if I go to bed and then wake up at 2, then I'm great. And so this is a picture of actually the largest crater on the visible side of the moon. It's called Bailey. And the interesting thing about it is you sometimes only see half of it. Half of it's on the far side. And it's only when the Earth wobbles, when the libration is correct, that you can actually see the whole thing. So, and one of the things that I love is seeing all the little craterlets, all the little subcraters inside a big crater. And I have never seen it as clear as I did yesterday. It was, sometimes when you're looking obliquely on, you can see how it's very elliptical there. It's a round crater, but it's because it's over at the edge. You're looking at it kind of side on. But that was very fun. Let's just choose some others. Oh yeah, I got some new pencils for my birthday. And so this was placed way up at the gorgeous. North Pole. Bailey's in the South Pole. And I don't know if you can see here, it says, very hard with my finger, it says Mare Frigoris. So that's the frozen sea. That's way up in the north. And it's not frozen, it's just a bunch of rock, but it was called the Mare Frigoris. Again, I'm just going to keep going through my sketchbook. Okay. Yeah. So one of my, there are favorite places. Once you spend a lot of time with the moon, you start getting to choose some parts that you really like. And the Sea of Crises, the Mare Crisium, is one of those. And then this is a lovely crater, which is right next to it, Cleomedes. And,
And is that a real square, like a real square kind of crater above it?
Craters take all sorts of shapes. I find that, I guess, depending on how the light catches it, you see, often they look polygonal. Yeah, so that one looks pretty square. The Lacus bonitatus, I'm not sure what that means. But yeah, lots of hexagonal craters to my eye. When you have the spaceship right over the moon, taking the picture, the moon straight down, then they're often more round. But
so we're looking at them on like from some sort of an angle.
Yeah,
and they end up
with the different heights of the rim and things, you get that. So there's a couple of things I want to talk about here. One, this is Schickard. It's one of the really large moons way over on the west.
And large craters.
It's so big that, it's a flat-bottomed, lava-filled, basalt-filled crater, very smooth, but you see this gradation from the lit to the shadow, and then you see the rim around it. And it's one of those things I just love. But another thing I want to point out is Schiller. Schiller is this guy here. And it kind of looks like it's two craters. I was sure when I started getting into my moon stuff that it was two craters, but it turns out that most craters are pretty round because, the way that craters form is it's a meteorite that crashes into the surface. And it turns out that for any angle of incidence down to about 5 degrees, the impact goes in and it makes a circular hole. But if it's just a glancing blow, like for this fellow, it's very funny doing this on Zoom. I'm always going
it's really hard to do, yeah.
So that one was one of the ones that really was a very oblique collision.
So it takes something really coming in really low to be able to do that. Yeah.
And okay, so something I want to say, very important, is the more you look at something, and it doesn't matter if we're talking about flowers or clouds or people or the moon, the more you see. And I'm not getting tired of it. I've been a selenophile, I think I can safely say, since Apollo missions in 1969. And I guess my sketching is only about 4 or 5 years old, but I just love looking through the eyepiece and discovering new things, and I don't get tired of it.
And so Leanne is asking, what's your setup for sketching? Do you use a red light to see the sketch pad, or what do you do?
Yeah. Okay. So let me just pull up a picture. Oh, no, I don't. No, I've been doing it just with the camera. That's right.
Yeah.
Anyway, so I'm going to share my screen. And share. Well, that's very fun. I can show you Enkin's Daily Moon also. There's lots of fun stuff to show there. But so I all the people in the club say I'm a frugal astronomer. I never spend a lot of money. I spent $50 on this. It's a lovely, it's a 6-inch diameter Newtonian. It's called Omcom. It's made in Vancouver. And the mount I bought from the now past president of our society, I did pay real money on the eyepieces. I did spend money there. But then let's just go to this. So so here's a pencil sharpener, and I use that to hold up a light, and that's an LED light that I put some tuck tape on to be read. And yeah, I started off doing black on white paper, pencils on white paper, and I realized I was frustrated because it's much better for me. This is idiosyncratic, to go on gray paper and use black and white pencils. And I find that I can draw what I'm seeing better. And that's what it's about. I'm not really drawing for other people. I'm drawing for myself. And then other people seem to like them.
Okay.
Does that answer the question?
Is that okay, Leanne? If you have anything else that you want to ask, you can put it. You could.
I'm not art trained or anything, and so I realize I have a lot of idiosyncrasies. One thing is this way of doing the dark. I don't want to color the whole thing black, so I just do these scribbles off the sides.
Jamie Marie asks, are we able to measure the depth of the craters? And if yes, how?
Okay, so the cheating way is now the Lunar Reconnaissance Orbiter has been going around and has been doing LiDAR, has been actually measuring it directly by the speed of how much time it takes for light to go from the spacecraft down to the moon. And they have wonderful, wonderful digital elevation model of the whole moon. But let's go back to, Cassini's time. So first of all, you have to measure how far the moon is from the Earth. And there's some wonderful ways where you get two different perspectives at different times. And you see how you get parallax. And you can work out that the moon is something like 400,000 kilometers from the Earth. And then you've got the length of those shadows. And from measuring very carefully as the moon goes around the Earth, it gets sunlight from different angles. And you can actually, if you're patient, you can actually see sometimes the shadows change with time. But by measuring very carefully how big those shadows are, you can figure out how deep the craters are, how big the peaks are. And this is a classic thing that they had done very well in the 18th and 19th centuries, using a micrometer to measure the lengths of the shadows. And wonderful, wonderful scholarship there.
Yeah. All right. David, do you want to unmute yourself and you can ask a question?
Yes. I'm already unmuted, I think.
No, I can hear you.
You're okay?
Yeah. Randy, I noticed you were at a sketching workshop a couple of days ago that I was also at. And I had this question because in the 40 minutes that I sketched what Bettina suggested, I was shocked.
You actually participated.
I did. In fact,
at the side of my desk while I was actually.
Could I share what I did, because I'm going to ask you a question based on what I
share. This is very exciting. Yes, it was Bettina Folger, I think, is at the Montreal Center, and she just did this beautiful drawing over about an hour. Look at that, David.
So I am totally not an artist. I know it's in my genes because my father was an artist, but the reason why I went into photography is I can't draw. So I just wanted to ask you how much time you spend, because with Bettina's coaching, I was shocked by what I was able to do. I was totally shocked.
Okay, so yesterday I woke up at 2 and set up, but there was lots of clouds, so I knew that it'd be a bit better. I guess by a bit before 3 I was really sketching, and it took me about an hour. And that's typical. I think a sketch for me is about an hour.
Mm-hmm. But I was impressed by the workflow she described, because she said not to get too preoccupied with one spot. So I just kept going. She was basically coaching me. So I said, all right, I won't get locked down into this area, because often I won't, which is really surprising because I don't approach problem solving that way. But when I draw, I tend to obsess with an area, right? And when she said, don't do that, so I said, okay, I'm just going to go over the whole thing as rapidly as I can without obsessing on any given area, and then go for another round, right?
And she said something very interesting, that the thing that attracts the eye is the last thing you drew.
Right.
So,
Right.
so she does a lot of foundation. A thing that she does, and I think it's experience and good equipment, but you don't see her pencil strokes. She makes very flat surfaces.
Yeah, and I was quite shocked when she kind of dissed the stump blenders, because when I mean, I have had some drawing training, and the people that I've drawn with say use the stump blender, right?
I have started. It's very recent for me, and part of the thing is I'm drawing pretty much in the dark, and so it's very hard to see the individual pencil strokes. So the stump thing, it looks like just a bunch of paper that's wrapped up.
It is.
And it just smudges things, and it feels a bit like cheating. But
I was surprised by her saying that her mom would have said that she was cheating. So or lazy. She said that her mom would say that she was lazy because she wasn't really trying to shade. She was just making it easy, right? Just.
I mean,
anyways.
One of the things, she was very, very capable of not drawing on the parts that she wanted to be light. And I cheat by having a white pencil.
I kind of know how to do that because I do watercolor. And okay, you can use white paint, but that's considered cheating. Like in watercolor, you're supposed to plan and either use Frisket to cover up the area, or just remember, don't put anything in that area, right?
So an interesting thing is white pencils are very different than the black ones. The white pencils, you don't have various shades. It's basically, it just makes white. And so what I'm doing is I'll use a pencil to kind of say, this is my scene. And then I'll do a bunch of white, and then I can put black over it to put detail.
But you know, one advantage you have by using that mid-tone paper is most of the moon's a mid-tone. So you're only applying the other pieces, right?
Yeah. Okay, another thing that's interesting, very different than a camera, is the eye is very interpretive. And so when we look at my pictures, and you know, this section here is a place where you can see that I actually put in a gradation, but there is a gradation going all the way across.
Yes.
And I'm not showing that. I'm kind of saying it's all one color.
I think that's okay, Randy. I think
my interpretation.
Exactly. I think in drawing, like we understand this even from cartoons. In drawing, we can have shortcut forms to imply certain things, and we accept that, right? So you can certainly do that.
Hey, I'd like to. Are there other questions?
Yeah, Randy, there is. Jamie is asked, what is the deepest crater?
I have no. Oh, I do know. I do know. The Chinese spaceship Chang'e 5 landed on the back side of the moon. Incredible technology. They had to send up a satellite to go on the far side of the moon to communicate with it, because we don't see the far side of the moon. And it's called something like the Aitkenson Basin. And the reason they went there is it's so deep, they think that they're going to be able to get through the crust of the moon into the deeper, they're going to get
Wow.
samples of the interior. And so no human has ever, well, no, something like 12 humans have seen this part of the moon, but it's all the people on the Earth have not. And yeah, so how deep is a good question. And I'm going to go by memory that it's well over a kilometer from the rim to the depths of it.
Okay.
And it's an old crater. It's filled with other craters.
Mhm.
But it's in the south, just on the backside.
Calvin, did you have any
So
other
I
questions
was
from YouTube?
gonna say, speaking of the backside of the moon, there is a question from the YouTube chat. Celestial Music Can says, I thought there are more Maria on the Earth side due to the Earth's gravity. Is there a higher density of craters on the non-Maria areas on the near side compared to the non-Maria far side density? So,
Oh, wow. Okay. So, very good question. So we're saying if we neglect the Maria, so we're looking at what we call the Southern Highlands. So it's not just there's this huge asymmetry. When you see a picture of the far side of the moon, it looks completely different. It looks completely cratered up. Yeah. But on the near side, there's a big difference between the west and the north, which is mostly Maria, but the southeast is the Southern Highlands. Now, if I understand the question, is the density of craters in the Southern Highlands higher or lower than typically on the far side? And I'm going to answer just theoretically that they shouldn't be. Most of the craters occurred before the moon was tidally locked. And so all the sides of the moon would have been facing all directions. I can't see fundamentally why there would be an anisotropy. And
there's a new word.
Oh, iso means same, trope is direction. So something that's isotropic is the same in all directions. Anisotropic means there's something different. The moon is highly anisotropic. You've got the big Maria, which are very dense, and so they are attracted towards the Earth. It's not a coincidence. There is a big reason why these basalt-filled basins are attracted towards the Earth. But the density, the number of craters per square whatever, I would think would be the same. But you know, there's still, you read about new processes to count the number of craters. It's not something that is easy. So, you know, with the Lunar Reconnaissance Orbiter and these fantastic images from all over the moon, they're now using these computer algorithms, artificial intelligence to identify all the craters. The problem is some of the big ones have been so eroded by young things coming on top, they're hard to recognize. And the small things are small. And so they're still trying to say, is that a crater? Is that not a crater? It's still a research direction. Now,
that's a good question.
There are catalogs of the, I don't know, what is it, 10,000, 50,000 craters. I have not seen a GIS, a Geographical Information System analysis looking at the density, but it would be dead easy to do because they've published that. And I love that. I mean, that's the sort of thing I can ask somebody at my work to look at.
Yeah, that's fascinating.
Good question.
Thought to answer the question about like you know, ignoring the Maria, like, you know, is each side of the moon have more craters? That's so really fascinating.
The Maria came later than
Right.
most of the craters. They crunched up over
Right. Filled it in.
the many little
Yeah.
craters of the
Yeah.
highlands.
Okay, Calvin, do you have anything more there on your end?
No, although Ben Dorman did pop into the
Oh.
YouTube chat talking about someone using sidewalk chalk, David Zinn, creating outlines, trying to draw and then does the shading in. Yeah, that's fascinating.
Of the moon
Who creates
on the
animal-
sidewalk.
Yeah.
Oh,
seems
there
to
you
be-
go. We could do
Um,
something on the pavement outside of the CU.
Right.
Yeah.
Yeah. Right. Okay.
So
think
I
that's
don't
about it.
see anything else.
If there is a moment, I would love to share some pictures of Enkinn's daily moon.
Certainly,
yes,
yeah,
of
we
course.
can do
Go
that
ahead.
and then
Yes,
close us
yeah.
off. Yeah.
And
Okay,
if people,
so-
if there are some people that have to go, then that's okay. But we can stay on for a little bit.
So
here.
I just have as a side hobby, I show every day on Facebook and Instagram under the name Enkinn's Daily Moon, pictures of the moon. So I just for fun, I thought I could show some. This is moons around my house, because everybody knows they can get me presents of moons and I will always be appreciative. So Eva, my wife, made me this nice cross stitch. That's a lovely 3D printed moon with a light
Beautiful.
inside. Come on. And posters and things.
And that was
globes.
the jigsaw puzzle.
No,
Oh.
that's a globe. That's a National Geographic globe.
Oh, okay.
You can also see some of my telescope collection in the background. I keep my telescopes in the front. Here are some of my books. This book here, that's my main atlas. Oh heavens, by a Hungarian fellow. Rutger. Anyway, so those are just some things, and there's Chris Hatfield's recent book, of course, and my coffee mug. These are pictures by a really fine amateur astronomer in Britain, David Graham.
Beautiful. Yeah.
Wow.
I really like his work.
I'm sorry, but I think he's using a little bit of smudging technique.
Oh, he certainly smudges.
Don't count Bettina.
That's a smudger right there.
Yeah. Yeah.
That's very much like the one I use.
Yeah.
So this is a Victoria photographer. What's her name? Cecile Guimau.
Beautiful.
And yeah, I really like her stuff. So every day I post a picture of the moon, and it's just for fun. But it's a good hobby. I spend a lot of time searching the internet for moons. This is a guy who does these photo manipulations, Justin Peters.
Yeah.
This one has been making the rounds. Everybody's sending me this picture lately.
Ah. Well, that's a good one. Ooh. I like
Kinda
the ones
woodsy.
that you do with the Japanese, the Japanese paintings
Yeah.
and ink drawings. I think those are beautiful.
So this was
That's a nice
cats,
one.
because I just recently got a cat. None of these are my cat. Oh, and then the CBC Nunavut has a very
Oh,
good Facebook page, and in the winter, people are always showing pictures of the moon and the aurora. Anyway, people are very welcome to, what do you call it? Like Enkinn's Daily Moon, and then you'll see one of these every day. Oh, then came Valentine's Day,
Yeah.
and so this was February 13th. I'm just showing you each day. So I just did a whole bunch of Valentines.
It shows the popularity, like the pop culture, right?
Lori,
of
this
that.
is important. The moon is a symbol that has been recognized throughout all time in every culture around the world. It is, the feminine, the passage
Yes,
of time,
yes.
night, It's just got so much symbolism and importance throughout the world. It's a great unifier. And that's one of the reasons that I love it so much. And here I am, 2,465. I'm I think I'm up over 2,800 now. I haven't had to repeat, and there's just so many pictures.
Yeah.
So what I'm doing in these pictures are different volcanoes around the world.
Oh,
look at that with the refraction. Wouldn't you like to do that one, David?
Yes.
Oh, that's fantastic.
Oh.
Oh.
Now, do you see what this is?
Yes.
This is
shadow.
Is that a mirage?
Mauna Kea?
No, this is from Mauna Kea.
Yes.
In Hawaii, looking at Mauna Hualaila, but it's the shadow of Mauna Kea over this other volcano with the moon above it.
Wow.
Oh, what a great picture, eh?
Just amazing.
There's so many times when you say that you wish you were the photographer.
So that's the moon over there. The moon is in the picture. It's just not very visible. Now I'm doing pictures of Mount Fuji.
Yeah. Oh, there is that. Is that the red and that, like, that looks like the ones. Oh no, it is Japanese.
That's Ted
I was
Harrison.
going to say.
It
is Ted Harrison. Okay.
That's the great Canadian artist who did this picture of Mount Fuji.
Now, why is there a red full moon and then a partial moon? What has he done there?
Okay, so do you think that is two moons, or do you think it's the sun and the moon?
Rising sun, yeah.
I think it might be the sun and the moon, especially since it's Japan.
I think it is.
And, the land of the rising sun and all that.
Okay.
I would imagine that's a Japanese sun, like in the red in their flag.
Yeah, I'm pretty sure.
And it's illuminating the moon, the crescent moon. That I mean, it's stylistic, but
great detail.
that would work for me.
Yeah.
I love how many different ways the moon is represented. These were pictures of alchemy.
Mm-hmm.
The sun and the moon are great. Sun is gold and moon is silver, and the transformation of elements and things. It's all part of the alchemy. Oh, and who's this? This was that great lady alchemist. I forget her name.
Oh, okay. This one was a fascinating one. That one that you just had on.
Oh, can you tell me something about it? I don't know anything about it.
No. I was going to say I need more information about this one. Like this one, I sat and watched and looked at for a long time and thought.
Oh, you're a good follower of Vacant Staley Moon.
Yes, I am. Yeah.
Oh, that's very flattering.
Yeah, so I recognize lots of these. Yeah. Have you done very much of any First Nations?
Yes. Now I'm kind of sensitive to that. I don't want to be cultural appropriation, so I did ask permission. There's a Facebook page called Northwest Carvers, and I got permission before I started using pictures from there.
Okay.
Anyway, I'm going to stop sharing.
Okay.
But the moon fascinates continuously. I'm not getting bored of it. I have a sextant, and I measure the diameter of the moon every time I see it. And
amazing.
I've been doing for over 30 years now. So starting in January 1990, I've been taking this very simple measurement of the moon, looking at it over time.
Wow. And you've got all of those, right? You've got it all the data.
Yeah, and I keep finding new things in it. It's you the more you look, the more you see.
Yeah.
And I think that's my message for just anybody's passion about anything is to spend time, go slow.
Yeah.
The more you look, the more you see.
Well, I'm going to say that we've been quite slow over the last couple of years in the pandemic. But we are going to be starting to ramp up again. Yay. This is our next Star Party is going to be on Saturday, May the 7th, which is International Astronomy Day around the world. And we are going to be, thank goodness, back down at the museum for our day program. Down there, we have all kinds of exhibitors. We've got different groups of people that are doing astronomy in Victoria. And come on down to the museum between 10 and 3. We'll have some presenters. We've got telescopes outside, children's programs, all of that kind of thing going on down at the museum. And then in the late afternoon, probably 5:30, 6 o'clock or so, the RASC is going to be part of a Cross Canada lunar webinar. So we are going to be dropping in across Canada to different centers and finding out what's happening with the moon all across Canada, kind of all within about an hour and a half. We're going to be going from East Coast to West Coast.
It'll be a
and
nice
north
quarter moon.
and north up in Yukon. And then starting at 7:30, we are so proud to say that we are going to be actually opening up the Center of the Universe again for our first in-person Star Party. That's going to be on May the 7th in the evening. And we're going to take things a little slow and a little easy, just because we're still trying to work out some of the COVID protocols. But we will be taking about 100 people that will be allowed to join us that night. Tickets will be available on Eventbrite probably by next weekend. We check out our website and make sure that you can kind of have a look.
Yes.
And the tickets are free.
The website will, I don't think it's up yet.
No,
the
it's not up
information,
yet.
But
It's not up
all
yet.
that information
Yep.
will be up there eventually soon.
Yeah, well,
and much
probably
more
by
info,
next
too.
weekend.
Yeah.
And you'll be, so just check in that we've got some things going on there. And our guest speaker there is going to be Chris Gaynor, our very
One and
own
only.
Chris Gaynor, who has written an absolutely fantastic, a set of books, my goodness, and has been has written a book that he's basically launching out on the evening on the Hubble, on the history of the Hubble Space Telescope. And we are going to be having some books for signing, and you can come along and get one. I've got lots of things happening, so we're really, really pleased. And we'll if we can do it, we are going to be doing some hybrid Zoom programming as well, especially of Chris's presentation. So if you can't get up to the center, then some or part, and maybe even David, if it's nice, we might even get some EAA going. We'll see what we can do.
Clear skies
about
that
getting
night,
things
guaranteed.
going, but lots and lots of stuff going on, but we'll be open. Hopefully we're still working with NRC in Ottawa to get final approvals and all of that kind of thing, but we're really happy to say that we'll be open. So please check our website, the FDAO Center of the Universe.org. Check the RASC website, which is Victoria at rasc.ca, and we'll be happy to have everybody possibly back in person again. So thanks everybody. Thank you for joining in. Thank you to Randy Enkin, who's our lovely solenophile. Thank you to Randy Attwood back in Mississauga, who was our guest speaker today, and David and Nathan. Thank you for helping out, and Amy for making sure that everything got done for our giveaway. So we'll just say good night to everybody, and have a nice Easter, Passover, whatever you are, whatever Ramadan. That's right. Whatever you are celebrating at this time.
Have a great night, everybody.
Yeah. Bye, Mai. Thank you.